Well, hi, James. Welcome to Cambridge Tech Week. You're head of quantum algorithm at Cambridge Consultants. Just interested in your thoughts on Cambridge Tech Week.
Oh, I'm really excited to be here. It's a really great event here, and it's being very well organised with lots of interesting talks. And I've heard lots of interesting things already and met lots of interesting people. And really, it's great to see the great technology in the Cambridge area being really put on show today in this week.
And we've only had half a day, and it's already jam-packed full.
It is all jam-packed.
And we've just come from the quantum panel. A number of things came out of that were interesting for me. And I thought the first one that really shouted out was, what's the short-term opportunity? How do you at Cambridge Consultants see that?
We see this as really short-term. It's all about building our capability and building people's understanding of how it's going to really change the world. So it's not going to just come as a big bang moment. We see it as really an incremental increase in capability over time, which will really change the world. And so it's really about understanding, how do we get that value now as these machines come online? How do we deal with the noise and the issues around that? And enabling us to be surprised about the potential applications. If we went back to the 1960s in classical computing, many of the applications which came out in the 60s and 70s, people wouldn't have imagined at that point in time. So we should be open to saying, how do we use these new devices? How do we use this new, different form of computation?
Your CEO this morning in his keynote talked about bringing value forward. And I think, as you're saying here, is one of the key areas where that applies in quantum. And how do you see quantum fitting in within a wider system?
So a quantum computer, it should never be used on its own. So we saw Carmen talking about this morning in the panel. It's all about using it in the wider system and finding the right use cases for the particular piece of quantum technology. So quantum computing fundamentally has many challenges attached to it. And there are things where a classical computer excels that a quantum computer does very badly. So just adding plain numbers together is something you should never get a quantum computer to do. You should go and ask a classical computer to do it instead. But for the places that quantum computing is useful, it is completely different to classical computing. It brings us a completely different capability to what we think of classically. It makes things that we currently think of as impossible, possible with a quantum computer. So it's all about understanding how to use the different computations together, how to make it to work as a whole. And that's going to take a lot of time and effort. And so we really need to get into it now to really bring that value and really see how we do it, and to make sure we're not going to do silly things. So at first glance, when we do the first sort of things, we will discover that actually the quantum computer makes something possible, but it makes another task hard classically. And so we have to work through those challenges to say, how do we use it all together? How do we push the hardware to its limit, using the classical for what it's good at and the quantum for what it's good at?
So the kind of the $64,000 question, if you like, is how do you get to those use cases? How do you get to the nub of what this technology potential can be realized and how it can be realized?
And that's where companies like Cambridge Consultants really plays a huge role for the industry and industries in general, because we bring both the domain knowledge, working with our partners in this space, but also the quantum knowledge together to really explore those use cases. And the issue is that we have to go back and we have to say, what do people think of as currently impossible? What are the computational challenges that people would love to tackle? For example, in thinking about the sort of drug design or in material and chemical design, what are the sort of computational challenges there? For example, simulating a chemical reaction. So a great example is in fertilizers. So the human race at the moment produces fertilizers at 300 degrees C and 20 atmospheres in the Haber-Bosch process. My pea plant in my garden is at 20 degrees C and 1 atmosphere. The reason we can't replicate that on an industrial scale is we don't understand that reaction mechanism. And quantum computing allows us the potential to explore that reaction mechanism and actually be able to understand how to do that on a commercial scale. But as part of that, we have to think about the whole workflow. So we know from the sort of academic literature, there's some great algorithms out there, but a great algorithm doesn't deliver me commercial value. So one of the really important challenges is, how do we build those workflows to bring around that commercial value? How do we actually get it to do something useful, not just be a toy machine?
Well, very interesting. You're sort of touching on an area that was also brought out a lot this morning, which is the availability of talent and skills. And yes, physics, PhDs and so forth needed, but then the discussion quickly moved on to others that are needed. Because actually, from what you've said, somebody who can translate those business requirements and that business problem, even if not articulated in the terms of quantum, is going to be very valuable as a translator between the technology and the business side. And is that what you're finding now with clients talking to you?
Yes, we're absolutely finding that. So I'm not a physicist by training, I'm a mathematician by training, so I come at this even from a different perspective from many of the people in the field already. And it's all about building multidisciplinary teams. It's all about bringing together people who can talk a language together. And actually that's the big challenge, is a language, and building people who can talk the language together in this space. Being able to solve those multidisciplinary challenges. As you say, bringing those business and domain experts with the quantum experts to say, what are the different things that we can do with quantum computing, and how do those translate back into actual value and actually useful use cases?
So one of the examples on the panel today was brought up by Howard Watson from my old company, talking about synchronization of networks and using quantum technologies to do that more efficiently, so you can basically free up a bit more capacity to send the stuff we really want, which is the data. Mm-hmm. And as we're all consuming more and more data, you can see there's a premium on that. Is that something that you see other use cases like that emerging that are not purely about security, although there is a secure element in that? Is that where you see the next sort of nearer term use cases coming from?
Yeah, so in many ways, if quantum computing was just about breaking cryptographic schemes, then we might as well all pack up and go home. Because governments will care, criminals will care, but 90% of the population won't care. So we might as well give up if that was everything. It's all about the wider use cases and the wider ability to change the world. It's all about being open for how it's going to change as well. So I like to use the analogy of the 1960s in classical computing. There we had it, we sort of knew it had some value. We knew some spaces, but we couldn't have imagined where classical computing has brought us now in the last 40 years. And quantum computing offers the promise of a revolution of the same scale. And it will be about understanding the heuristic uses. Yes, we have some great use cases in cryptography, but it's about how we use it in a much more general and wide ranging possibilities, which will bring the real value here. And so, for example, as you say, taking it and being inventive and creative in how we use it. For example, using the timing here to improve synchronicity across the network routing is a big thing. Thinking about the optimization things, how do we think about cases where at the moment we have to do it offline? What would it mean if we could bring it online? If we could change that from an offline optimization to an online optimization to enable us to be more reactive in what we do, for example, in the power grid. So rather than having to treat our wind power as a very constant thing, is what we have to partially do at the moment. If we were doing things online, then we would be much more efficient in how we use our systems and our technologies.
Because the wind doesn't blow all the time,
exactly.
So it's a variable, just like the sunshine.
Yeah, exactly.
So yes, those sort of use cases bring it to life. I'd just like to say, on behalf of Cambridge Tech Week Committee, thank you so much for supporting this initiative. This is the first year, and we've needed Cambridge major companies like Cambridge Consultants to support us in getting this going. As you can see this morning, we've had a great turnout. So thank you very much, James.
Thank you, Ed. It's been a very exciting week, and I'm looking forward to the rest of the events.